How's it going, guys? We're going to talk about how to name chemical compounds. So the first one we're going to start off with here is Na2O. It's a pretty simple one. Basically, we're going to start off naming it with the first element that's there. So that's going to be sodium something. Now, in this case, because it's only two elements involved, and neither one individually, if it dissociates, is a compound, it would just be sodium and oxygen. We can just put oxide. So that hyphen there, that end piece, IDE, that's going to be whenever you have just two different elements, that's going to be on the anion. So basically, if it's on this side of the periodic table, it's more likely to be, well, it's going to be a cation. So all of this column will be plus ones, these are going to be plus twos, and then on the far side, you have these are going to be -1, -2, and then it starts to get a little bit more dicey when you get closer to the middle, but those are pretty much the steadfast rules. And then for the middle, for the metals, the metalloids, it gets pretty variable from time to time. For instance, like copper can have a couple different charges, as well as like iron and lead, but we'll get into that more in the next problems. So number 2, let's go for Al2S3. So 2 aluminums and 3 sulfurs. In this case, again, it's the same type of formula. There's a cation and anion. We're just going to name it with the first one, aluminum, and then we have sulfur. So instead of writing aluminum sulfur, we're going to write aluminum sulfide. So we just have that IDE there on the end. So those ones are pretty straightforward. It gets a little bit more complex though when you have things that dissociate into compounds. So for instance, SO4 is one that we could do next. We know, just like the other ones, Sr is the element, strontium. That's going to be the first part of the name. However, if you're looking at this, it might be tricky because you might think, is it multiple different elements going on? Are they dissociating? One thing that I like to do when I'm working on these problems is see what they would break down into. So if you know the charge of one or the other, like say for example, we have strontium, we know is in this second column here. So we can say it's a 2+. If it breaks down into Sr 2+ plus SO4, there's only one SO4 in this. So that means we have to know that SO4 has a minus charge. That makes it a little bit easier. And a lot of professors will give some kind of chart that looks similar to this, where you get an example of a lot of the common ones. For example, this one is SO4. That's going to be sulfate. And again, we get that confirmation it's a 2-. So it's just going to be strontium sulfate. If you aren't given those, it's easy enough to find a chart like that just by Googling it, and then you can kind of memorize the common ones and go from there. So the next one we're going to go for is, let's see, NiIO3 2. In this case, it's a little bit trickier because, first of all, nickel is another one that we have to kind of worry about. It's in the middle, and the charges can sometimes vary. Then IO3 is like a less common compound that will dissociate, but we can kind of, if we can figure out the charge of one, like say for instance you knew the charge of like the IO3, you could go from there. That's iodate, and it is a -1 charge. If that breaks down, that's 3-, and we know there's 2 of them. So that means that the net charge of the IO3 there's 2 of them, so 2 times -1 is -2, which means to have a neutral charge, that nickel has to be a 2+. So in this case, with a lot of those metals that are variable in their charges, what you're going to do is, instead of it just being nickel iodate, it's going to be nickel, and then we include the charge there with Roman numerals 2 iodate. These ones were the ones that were the most challenging for me, because you kind of have to always be watching out for them. And then, you know, do you add the charge, do you not add the charge? It's pretty much you never will have to if it's clear cut, but if the charge is variable, I think that's kind of, you're confirming what that is. And then we'll do, let's see here, MgNO3 2. Here's another one. NO3 is one of the most common that you'll see. And if you, again, didn't know the charge, just check out the periodic table and see what your cation would be. So for magnesium, that's going to be a 2+ because it's in the second column. So we'll see if it dissociates into Mg2+, NO3. If this has a positive 2 charge, and there's 2 NO3s to make it a neutral charge, that means each NO3 has to be a -1 charge. So that helps us with that. And then start naming it with the first element. And then usually for the more common ones, you can either try to memorize them or find them. If you have a chart that's provided, that would be great. But that's obviously not always going to be the case. So in this case, there's some common ones are NO3- and NO2-. There's different tricks to try and remember the names, but this one is going to be, in this problem, it's the NO3-, which is nitrate, nitrate, and then nitrite with an I is the single one. So once you get a hang of all these endings, you can kind of apply them to some of the other ones. So it's the same, I believe, with sulfite is 2- with a 4. Anyway, here's the chart if anyone wants to take a look. It might seem kind of overwhelming, but it's not too bad. Once you practice a lot of these problems, you'll get the memory of each compound pretty quickly, and then the periodic table is your friend. Use it for figuring out the charges, and then you can go from there. Hopefully this helps someone.